Chapter 2, Fundamental Data Types, Part 4. Arithmetic. In Java you can do math, addition, subtraction, multiplication, division, all stuff you're very familiar with from your math class. You just have to write it a little bit differently. So in algebra you might write a plus b divided by 2, but in Java you have to put a plus b in parentheses, meaning do this first, and then the slash, the one that's on the same key as the question mark, is how you say divided by in Java, and then 2. It follows the same precedence as you did in algebra. Please excuse my dear Aunt Sally, or PEMDAS. Do parentheses first, then exponents, but exponents are handled differently in Java, so we're going to table that for a moment. Multiply and divide have the same precedence, and add and subtract. So remember PEMDAS, and it will definitely help you out when evaluating expressions in Java. You can mix number types, and what does that mean? You can provide an expression that includes both ints and doubles. It's safe to convert a value from an integer to a double because no precision is lost. 2 is the same as 2.0. That's fine. But going the other way can be dangerous. So when we convert 3.45789 to an int, what happens to the 0.45789? It's lost, and that's called a possible loss of precision error. And you'll get that error, possible loss of precision, when you're trying to convert a double to an int. We can force it. We can manipulate that, and we'll learn how to do that, because sometimes you want to say, listen, Java, I don't care. Get rid of those decimal places. They don't mean much to me anyway. So if we look at this example, double area, comma, pi equals 3.14, int radius equals 3, area equals radius times pi. What happens is we say radius times radius, 3 times 3 is 9, that's still an int, times 3.14, 9 times 3.14, 3.14 is a double, 9 is an int. Java is going to promote that int to a double, so it's going to be 9.0, multiply it by the 3.14. I don't know what it comes up with, 27 point something or other, and that result will be stored in area. So we can automatically promote an int to a double, but we can't take a double and make it into an int. So we can also increment a variable. That means to add 1 to it. Incrementing means adding 1. And here's how that happens. If we say, let's do this, if we have counter equals counter plus 1, it takes the value that's in counter, in this example it's 3, adds 1 to it, which comes up with 4, and then stores the result back into counter. So frequently in programming we want to count when something happens. So it's common for us to use counters. We're going to do the expression on the right first and then store it in the location on the left. Counter equals counter plus 1. We can there's a shortcut provided because we do it so frequently. There is a shortcut provided for incrementing, and it is the plus plus operator. So 2 plus signs right next to each other with no space between. So the long way would be to say counter equals counter plus 1. But as a shortcut, we can say counter plus plus. Does the exact same thing. We can also subtract 1, use decrementing. Counter equals counter minus 1. We can say counter minus minus, and it will do the same thing. It's less typing. There is no plus 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 plus. We can't add 2. We can only plus plus only adds 1. If we wanted to add 2, we would have to say counter equals counter plus 2. Integer division and remainder. So when both parts of an operation are int, the result is going to be an int. So if we say int result equals 7 divided by 4, how many times does 4 go into 7? Once, with a remainder of 3, right? Remember that from your long division? So the value that is stored in result as a result of this expression is going to be 1. The remainder is lost. The remainder is gone. So sometimes we want to hang on to that remainder. Sometimes we need it. So if we want the remainder, we can say int remainder equals 7 modulus 4. That percent sign is read modulus, and that returns the remainder from integer division. So 7 divided by 4, 4 goes into 7 one time with a remainder of 3. So the result of this expression would be 3. Sometimes it's called modulo divide, but I don't hear that very much. If you focus on modulus, you'll be just fine. So the division sign, the slash, gives us how many times 4 goes into 7 without the remainder, and then the modulus, the percent sign, gives us the remainder. that only works with integer division. When we're dealing with doubles or floating point numbers, it's handled differently. We get the remainder with floating point numbers. In Java, there are no symbols to calculate the exponent or to calculate a square root. As we mentioned earlier, there's no exponents in Java. We have to use a method that's been written for that. And the method is the POW method will calculate an exponent. So if we want to calculate b times, parenthesis, 1 plus r over 100 raised to the power of n, we can say b asterisk math.pow. That's the method to calculate the exponent. In parentheses, we have 1 plus r divided by 100, comma, n. That n is the exponent that we want to raise this expression to. So math.pow takes two arguments, the base and the exponent. So what number do we want to raise to what power? If we want to calculate a square root, we have to use math.squareroot, math.sqrt. Notice the word math has an uppercase M in it because it's a class name. So math.pow and math.squareroot will raise a number to a power and will return a square root. Here is a list of mathematical methods. Honestly, we don't need to worry about any of them except math.pow and math.squareroot. If we need any of the rest later, we'll look them up, but only focus right now on math.pow and math.squareroot. So if we want to convert a floating point to integer conversion, we have to tell Java, listen, it's okay to get rid of the decimal places. Even if there aren't any, even if we have a double that stores like 5.0, we still have to say to Java, hey, it's fine with me if you get rid of these decimal places, the 0.0. And to do that, you use what's known as a cast. Casting forces one data type to become another. For example, if we have a variable called balance and we say double balance equals total plus tax, and then we have int dollars equals balance, we can't take a double and put it into an int. So our solution is here, int dollars equals int balance. Notice that we put the data type in parentheses to the left of the double, of the variable that's a double, and that will say, yo Java, cut off those decimal places. And that's how we cast. We will lose the fractional part, and we're saying that's okay with us. The cast syntax is to have the data type we want to cast to in parentheses to the left of the expression or the variable that we want to be converted. Casting is very powerful and it should be used carefully. You have to be sure you want to cut off those decimal places. And if we want to round a number to the nearest whole number, it's better if we use math.round because casting will chop off the decimal places. It's not going to round it. It's going to completely chop it off. It's going to say, I don't care if it's 3.99, it's getting rid of the 0.99. The answer will be 3. If we want to round it, we should use math.round instead. Here are some arithmetic expressions and their their equivalent in Java. Notice down at the bottom, math.pi, there is a constant declared in the math class to represent pi. And that's a good thing to use because it's more precise, more accurate than 3.14. And it's already created for us. So if you ever need pi, go with math.pi. I'll leave you to hit the pause button and examine the rest of these expressions on your own. It's a common error to unintended integer division. So here they're showing some statements that we haven't gotten to yet, getting integers for S1, S2, and S3. But if we want to calculate the average of those three numbers, those three integers, S1, S2, and S3, and we add them together and then divide them by 3, we're not going to get the accurate average. Why? We add the 3 together and then you divide by 3. That should be the average. The problem is because they're all integers and we're dividing by an integer, an int divided by an int results in an int. So the decimal place is going to be 0.0. It's not going to have the result that we expect. Easy fix for this is to use 3.0 rather than 3. Unbalanced parentheses. It's very common to not have a closing parenthesis for every open parenthesis. Something to watch out for. And it's hard to find. I mean, if you're debugging your code, sometimes it's helpful to have another person keep track of it for you, or to debug for you. So if you can't find the error, sometimes another set of eyes will work. Some people find it handy to count how many parentheses you have. So add 1 for every open parenthesis. This didn't line up right, but if we add 1 for every open parenthesis and we subtract 1 for every closed parenthesis, we should wind up with 0. Let's see, 1, 2, 1, 0, -1, -2. Yeah, that didn't work. We have unbalanced parentheses there in that last one.